Today, we're jumping into something really fundamental that's shifting under the surface in AI. We're moving way past those, static chatbots we've gotten used to. We're entering this new phase where AI doesn't just chat, it actually does things. And the key, the absolute linchpin here, seems to be something called the Model Context Protocol, MCP for short. So our plan today is to dig into the sources we've gathered and pull out the core insights for you to really get how MCP is defining the next wave of intelligent systems.
It really is a massive shift. For ages, AI was mostly reactive. It listened, processed, responded, mostly talk. But now we're seeing this whole new category emerge. People are calling them fully autonomous agents. And these agents can actually, browse the web, build things, retrieve data, execute commands. It's not just understanding anymore. It's about doing.
Okay, let's unpack that. What makes these new AI agents different? From what we've seen, it's this combination, right? They bring together memory, access to APIs, goal setting, real-time feedback, all in one workflow. And the really interesting part, they don't just sit there waiting for you to tell them what to do. They actively pursue objectives. It's like an AI that takes initiative.
Yeah.
We're starting to see hints of this in things like AutoGPT, Claude Desktop, even some of those advanced enterprise copilots.
Right. And for these agents to actually work properly out in the real world, they need a few key things. They need consistent tool access, persistent memory, structured context, and they need to integrate smoothly with basically any data source.
Yeah.
A huge problem up till now. Fragmentation. Just everything was disconnected. Think about it. Each AI framework, each tool had its own way of letting an agent connect, if it even could. So you ended up with agents that were, really smart, but also siloed. They couldn't reliably connect to outside tools or data. That really held them back.
And that's exactly where MCP comes into the picture, right, to fix that fragmentation. It's being called the actual backbone of agentic AI. There was this great analogy in one of the sources. Think of MCP as the USB for artificial intelligence agents.
Yeah, that USB analogy just clicks, doesn't it? It makes immediate sense. If you zoom out, MCP is basically acting as this universal plug-and-play interface.
Right.
It's the connector between AI models like GPT, Claude, whatever, and the tools, APIs, and real-time workflows they absolutely need to function out there. It standardizes how agents figure out what tools are available, how they pass information back and forth, the context, and how they made decisions across different platforms, different ecosystems. The MCP server part is that crucial connective layer, and that layer, that's what's defining the next era of intelligent action.
So practically speaking, what's the big win here for developers? What was the main frustration MCP gets rid of?
Well, the core issue MCP tackles head-on is this. Before, every AI agent reinvents the wheel, seriously. Developers had to manually write these super specific, often really fragile, text instructions prompts just to try and get the AI to use an external tool. And these were so brittle, like one tiny change in the tool or the AI, and boom, the whole thing could break. Super frustrating, very error-prone. MCP changes that by providing a shared language, a common ground between the automated agents and the tools they need to use. It sets clear rules for how models discover capabilities, how they request actions, and how the responses come back all structured. And that is what unlocks flexibility and scale. Suddenly, AI assistants can easily find out what tools they have, ask for real-time data or services, and understand the answers without guesswork. No more hard-coding logic for every single tool into every single agent.
Right. So this shared language, this standardization, it basically lets agents step outside their, box.
Yeah.
They can move beyond just processing text into handling real complex tasks, actual AI native workflows. And you mentioned it even helps in sensitive areas, like healthcare or finance, by making interactions with data sources secure and scalable.
Exactly. That opens up a whole range of applications that were just too risky or complex before.
Okay, I get the why, but how does MCP actually do this? How does it manage to be this universal adapter? So sources mentioned it has 3 coordinated parts.
That's right. First, there's the MCP server. You can think of this as like the central hub or the execution context for the tools. It holds all the definitions for the tools, the API schemas, workflow templates, even rules about how they can be use constraints. So instead of an agent just guessing or relying on brittle prompts, it queries this MCP server. It gets reliable, structured metadata from trusted data sources in real time. It knows exactly what tools are available and how to use them because it's looking at a live curated catalog. Okay, then number 2 is the MCP client.
This piece gets embedded right inside the AI assistant itself, or maybe in the orchestration layer. That's kind of the manager coordinating the AI's tasks, or even the platform the AI runs on. The client is vital, keeps track of the conversation context, figures out what the agent is trying to do, formats the request correctly for the tools, and then understands the responses when they come back. Basically, it's the agent's secure and reliable connection to the outside world via the MCP server. And the third piece is the MCP protocol itself. This is the actual shared logic. It's the set of rules governing how information flows between the agent, the tool it wants to use, and the wider environment. It defines everything: how tools describe themselves, how context gets passed around in a structured way, how tools respond. This whole setup server client protocol is what allows AI to become genuinely autonomous, modular, and secure. It gives the agent a clear, unified answer when it asks itself things like, okay, what tools do I have? What state are they in? What can I actually do right now?
All right, let's make this concrete. Seeing MCP in action probably makes it click even more. The big draw for developers is these unified tool schemas, right? You define an integration once, and then you can reuse it everywhere, different agents, different platforms, even different AI models. That sounds like a huge time saver. Let's take AutoGPT as an example. Before MCP, getting to use external tools often meant relying on those brittle prompt hacks we talked about, very specific, fragile text commands. But when you integrate MCP, that mess apparently just goes away. The agent queries a live catalog of MCP tools. It gets clean execution, much more dynamic and reliable. And what about Claude Desktop? How does MCP help there? The sources say it gets way more powerful. It can securely issue shell commands, grab local system data, trigger OS-level functions, and crucially, it does this without leaking private context. The MCP client must be managing that secure connection really carefully.
Exactly. And broaden that out to general automated workflows. Think about an AI agent connecting to your company's CRM, your email, your calendar. With MCP, it could potentially track sales leads, generate reports, and follow-up emails, all by calling the right tools through the MCP server. No need to hard-code prompts or patch APIs together. This kind of standardized approach makes AI agents suddenly practical for complex jobs in, say, sales, operations, research, even science. They can pull data from live dashboards or query databases directly when needed. And what's really cool is adding a new tool to an agent's arsenal becomes super easy, almost with zero disruption. You just publish the new tool's definition to the MCP servers that the agent can access. Instantly, the agent can discover it and start using it through the standard MCP interface. This is what enables those really complex things like enterprise automations, AI platform orchestration, and those fascinating autonomous research loops. It makes them feasible at scale.
Okay, this all sounds great for making AI agents more capable and easier to build. But you touched on security earlier. What happens when these agents need to deal with really sensitive stuff? I mean, accessing internal company databases, querying regulated financial or health data, running compliance checks. In those situations, you need more than just connectivity. You need rock-solid guarantees about privacy and security, right?
Absolutely critical question. And that's where this other piece comes in. Combining MCP with something called confidential AI. Think of things like Intel TDX. These are called Trusted Execution Environments, or TEEs.
Right.
Imagine them as ultra-secure, isolated vaults built right into the computer hardware. Now, if you run the MCP server inside one of these TEEs, platforms can guarantee that all agent-tool interactions occur in isolated, hardware-enforced enclaves. It's a huge deal for security because what it means is the AI model itself, it never sees the raw, sensitive data, the tool it's interacting with. It doesn't have to expose its internal workings. And every single action taken is logged, verified, and auditable within that secure enclave. This basically transforms MCP into a compliance-grade execution substrate. It becomes the very foundation for private AI infrastructure. This is absolutely vital for sectors like healthcare, finance, anywhere dealing with regulated industries where user data and context must be kept completely private and secure by design.
Wow, okay. So putting it all together, AI agents aren't just a future concept. They're rapidly becoming the new interface layer for how we interact with technology. They can reason, plan, automate complex tasks.
Yeah.
And MCP is, well, it really is the bridge, the crucial link connecting that intelligent reasoning to real-world execution. It provides the standard needed to finally unify tools, APIs, and data for these agents.
Exactly. And when you layer on confidential AI, like we just discussed, MCP unlocks this entirely new standard. You get private, composable, accountable systems actually built for those high-stakes, sensitive workflows. It's how we shift from, black box AI, where you're just speculating about what's happening, to transparent, verifiable infrastructure you can actually trust.
So really, understanding MCP means understanding where intelligent action is heading. It's the tech that makes AI agents truly practical, the plumbing that lets different AI systems connect, adapt, and act together at scale. It makes you wonder, doesn't it? As this capability spreads, what will you build with this new understanding?